reverse potential generated prohibits the voltmeter for its full reading. How? Let us see. So we are moving, for example, we have used the ideal case, we have used the salt breeze, and the reading of the voltmeter was 5 volt. Now we are not using the salt breeze, we are using a glass tube, and liquid junction potential is 1 volt. Now it is a reverse voltage, so the net voltage measured by the voltmeter will be 5 minus 1, 4 volt. So this is not good. So what is the function of salt breeze? Now important function, it prevents the liquid junction potential. Salt breeze prevents the liquid junction potential easily without intermixing the actual the solution. Without intermixing the solution, it helps in migration of the cations and anions across the salt breeze. Okay, without actually intermixing the solution. So we use cotton wool so that the agar paste does not come down. We use this cotton wool. This paste and the salt does not come down and mix into the solution. So we use cotton wool. So actually the salt does not come down and mix into the solution. Now we have studied 3 components: cathode, anode and salt breeze. Now we are studying Daniell cell. Daniell cell is an example of, you can say, galvanic cell or the voltaic cell. 2 names are there, galvanic cell or voltaic cell, and this is the name Daniell cell is specific. Whenever examiner say Daniell cell, it means we have to understand automatically that cathode is made up of copper and anode is made up of zinc. Okay, left oxidation half cell zinc, reduction half cell copper. Everybody understands that? The metal which is more reactive will always act as oxidation half cell, or you can say anode, and the metal which is less reactive will always act as cathode. So obviously more reactive means it will lose electron, and the electron will be received or gained by the copper, which will be acting as cathode. So copper is used as an electrode in reduction half cell, zinc is used as an electrode in oxidation half cell. But if we take another case of copper and silver, then copper is more reactive than silver. So obviously silver is less reactive, which means it is used as cathode, and copper is used as anode. Okay, now you will be having a question, sir, how do we come to know which is more reactive, which is less reactive? That will be understood by electrochemical series. Electrochemical series is something which we will understand at a later stage. We don't need to cram it. It is a series, we will understand it. No big deal, isn't it? Now let us redraw the figure again. The complete cell, oxidation half cell on the left hand side with zinc, and reduction half cell with copper on the right hand side, isn't it? This is copper is acting as cathode, and then zinc is acting as anode. Anode means oxidation. Salt breeze contains potassium chloride, KCl. If it is copper, then it must be having Cu2 positive. If it is zinc, then it must be having Zn2 positive. Same electrode, same cations. So what is happening? Zinc is losing 2 electrons, copper is gaining 2 electrons. So we have discussed concentration of zinc in the solution will increase, mass of the rod will decrease because the metal atom are dissolving into the solution, and oxidation is happening. The potential generated is called E oxidation. Okay, on the right hand side, on the right half cell, concentration decreases because the cations are decreasing in the solution because they are gaining electron coming onto the electrode. Mass rod thickens, mass of the rod increases, and reduction happens, and the potential generated on the right hand cell is called E reduction because copper and zinc are used. That's why we call it Daniell cell. E oxidation is represented as it initially it was zinc solid. That's why we have used a straight line between zinc and zinc 2 positive, and it is converted into zinc ion. So reduction potential, copper 2 positive initially, and then on the right hand side it becomes copper atom. This figure we can study easily. This is the representation of the battery. Negative terminal means negative sign. Negative sign means electron are being emitted. It means on this side cathode is used, isn't it? And on this side anode is used. Current is always having the direction opposite to the flow of electrons. So let us go to the figure again and we will see to it. Now this is the figure again and we are watching it, and what we have watched, tell me dear students. Now you seen the, so that you can understand it. Again I am going back. Okay, very well. We are taking it, and now we are reaching at Daniel cell. Okay, and then we have understood. So anode means negative terminal of the battery. At anode sign we will be writing negative sign, and at cathode we will be writing positive sign. But charge wise, yes, charge wise it is positive always. How so? Because number of cations in the oxidation half cell is increasing, positive charge is increasing. So charge wise we write anode as positive, but it is for battery terminal it is negative. Okay, and cathode means charge wise it is negative, but it is positive terminal of the battery. So reduction occurs at positive terminal. It is gaining because it is positive, that's why it is gaining electrons. Okay, positive is attracting the negative charge. So now my interest is to add both the half cell reaction. Now I am adding both of them, oxidation half reaction, reduction half reaction. And how do we add the reaction? We add the reaction always in such a way that number of electrons get cancelled out. Number of electrons get cancelled out. Easy, very easy. Zinc copper 2 positive gives zinc 2 positive copper, isn't it? Electron get cancelled out. This final reaction will tell us the value of n equal to 2, number of electrons participating in a redox reaction. And from this reaction, what is the reaction coefficient? Tell me, what is the reaction coefficient? Over here Q equal to, what is the reaction coefficient? Tell me students. Reaction coefficient means concentration of the products, all species of the product raised to power their corresponding stoichiometric coefficient upon concentration of all the species of reactants raised to power their stoichiometric coefficient. And the concentration of solid will be taken as 1:1. This solid is copper and this solid is zinc. So zinc 2 positive upon copper 2 positive concentration, that is called reaction coefficient. Now for the complete cell, what is E naught in standard state? Let us say the pressure is 1 bar. Okay, if the pressure is 1 bar and concentration is 1 molar and temperature is 298 Kelvin. Now we know very well that cell potential, I mean the voltage, is always a scalar quantity. Scalar quantity means 1 plus 2 equal to 3. It is not a vector quantity. So we will simply add, what do we add? We add the potential generated by the oxidation half cell and the potential generated by the reduction half cell. Oxidation and reduction, we will add both the potential. That will give us standard cell potential. That will give us standard cell potential. So how do we write it? This implies E naught equal to, look, oxidation is shown, zinc is going to zinc 2 positive, and look here reduction is shown, copper is going to, copper 2 positive is going to copper atom. So this is obviously oxidation potential and this is obviously reduction potential. And we know very well oxidation potential is inverse, means negative of reduction potential for a half cell. Keep it in mind. Okay, for a half cell oxidation potential is negative of reduction potential. For example, zinc has got 0.41 volt as reduction potential minus, so oxidation potential will be 0.41 volt positive. This is reduction potential, this is oxidation potential. Negative negative will become positive. Everybody understands that? Oxidation will be